This is going to be the first free response that you see if you really haven't taken the pre-calc class, right? But if you did, then you're going to see plenty of these. You have two functions, function f and function g. It says, for the graph of function f and g are shown from 0 to 5. What is a different quotient, right? A different quotient that best approximate the instantaneous rate of change of g at x equal to 2.5. So what that means is you have to look at function g. So function g is this function right here. They gave you a hint. You want different quotient. Quotient means you divide. Difference means you subtract. Instantaneous rate of change, that means slope at this point. Okay? You don't have a function, so you can't really plug in that value or plug in 2x value and find the slope. But you have a graph. 2.5 is right here. So here's 2.5. Okay? I'm not looking for the y value. I'm looking for the rate of change, which is the slope. So to find that, I'm going to pick 2 points that 2.5 is in between. You guys recall that? And then find the slope. So for part A, this is 7, and this is part A. To find the slope at 2.5, I can find the difference in my y. In this case, that is g of 3 minus g of 2, because 2.5 is in between. I don't really need to find two numbers very close to 2.5, because on a line, the slope are always the same. So I can just pick these two. And then the change in x is 3 minus 2. So the y value at 3 is going to be 1, minus the y value at 2 is going to be 4 over 1. So that's going to give you a negative 3. That's your answer. And you can see it on the graph, right? In this case, to go from this point to this point, you go down 3 over 1. That's why it's a negative 3. Are we good? But that's how you show work, because it's a free response. You can't just write your number. B. Let h be the function defined. So this is your h. I want to find the limit as x approaches 3 of h of x, or explain why the limit does not exist. Use correct limit notation in your answer. So I want to find the limit as x approaches 3 of h of x. I know what h of x is. It's this composition. So I'm going to write that. The limit as x approaches 3 of g of f of x. Now, do you guys remember we talked about this one? Yes? In order to find the limit of composition, I need to make sure I find the limit of the inner function first. You guys good? So what I need to do is I need to find, I'm going to go over here, the limit as x approaches 3 of f of x first. Well, here's f. As x approaches 3 right here, you can see your function is approaching 3 from above. You guys see that? So here, my function is approaching 3 from above. That means the number 3 here, the value that I have here, which is approaching 3. Well, it's approaching 2. Sorry, it's approaching 2, right? As x approaches 3, your function is approaching 2 from above of 2. Above of 2 means numbers are bigger than 2. So keep that in mind. So you are approaching 2, but these numbers are bigger than 2. Are you okay? So we're going to say above or value bigger than 2, greater than 2. Now, this is only for you. We don't write that on the AP exam. Is that good? This is what they read. Now that I know that, I'm going to go ahead and find my limit as x approach this number for function g. Because remember, this is my y. But when you plug in that y changed now to x for g. So this is what you're going to do now. You're going to find the limit as x approach this 2. But because the 2 that you have here are value greater than 2, that means x is approaching 2 from the right, because the right are the x value that are bigger than 2. So this y value, when you put it in here for g, it's become the x value for g. And for x to be bigger than 2 or from the right of 2. And this is for g of x now. So now you can look at x approach 2, here's 2. But from the right of 2, this is the right of 2. You guys see that? So number closest to 2. So the graph that are closest to 2 on the right is this one. And you can see that the function is going up to 4. So my answer is 4. Questions on that? So that y value, once you find it, it is the x value that you're going to put in to find the limit of function g. Okay? Questions on that? Now we're going to move on to C. It says, let k be the function defined by k of x, which is 4 minus f of x times g of x. Consider x equal to 2 and x equal to 4. Determine whether k, function k, is continuous at each one of these values. You justify your answer using limit notation. So what I want is I want to check to see if the function is continuous at these values. So to check for continuity, you have to have those 3 checks. You guys good? So we're going to first check 2 first. So this is part C. So I'm going to write C here. Yeah? Check. This is function k. Check if k is continuous at x equal to 2. So these are my 3 checks. K at 2 have to exist. So I'm going to write my setup first. The limit as x approaches 2 of my function have to exist. Okay? And last but not least, well, we'll write the 3 later. So now what I want to know is, well, what's k? So I'm going to write function k over here. That way I don't have to go back and forth and look at it, okay? Function k is this one. So that's 4 minus f of x times g of x. That's my function. Okay? I need the graph. That's why I need to do this one. If I want to find out what the y value is when x is 2 for function k, I need to plug in 2 right there. You guys good? Yeah? So we're going to do that. So that's going to be 4 minus f of 2 times g of 2. Okay. So now I'm going to have to find out what is f at 2. You guys see it? Right here at 2, your y value is 4. That's your point. So that's a 4. Time g at 2. So here's g. At 2, you don't look at this point. You look at the closed circle, which is 4 again. Do you guys see that? At 2, that doesn't have a point. And that one does. So you have to use that one. So that's going to be 4. But then this is 0 times 4 is also going to be 0. So that means the y value when x is 2 for function k is 0. Are we good? Next, I need to find the limit. So I have to write the limit now of 4 minus f of x times g of x. When you find limits, please note you can break them apart and find the limits that way. Are we good? Because this is a multiplication, you can break the limits apart and find that limit. So this is what I mean. You can find what is the limit as x approach 2, right? Of 4 minus f of x first. and then times the limit as x approaches 2 of g of x. So we can break them apart and find the limit that way. Are we okay? So now let's find the limit for 4 minus f of x. 4 is a constant. So the limit as x approaches 2 of a constant is that same constant. Okay? What about the limit as x approaches 2 of function f? What would your value be? What would your value be? You guys see it? Here's f, right? As x approaches 2, the function is approaching 4. You guys see that? So from the left, the function is the movement. The limit is the movement. So from the left of 2 and from the right of 2, the function is approaching 4. So this is what I got for this one. I got 4 minus 4, which is 0. Are we okay? So I got 0 here. Times the limit as x approaches 2 of g of x. But here's the problem. Look at the limit as x approaches 2 of g of x. What do you notice? It's a jump discontinuity. So that means your limit from the left go to -1, and the limits as x approach 2 from the right go to 4. The limit does not exist when x approaches 2 for function g. You guys see that? However, because you multiply to 0, yes? If you take the limit from the left, which is approaching -1, and you times 0, you get 0. If you take the limit from the right of 2, which is approaching 4, and you times 0, you still get 0. So now you see that the limit from the left and from the right, if I take this and multiply to 0, I get 0. Do you guys see that? So while this does not exist, but if I look at both-sided limit or one-sided limit separately, when I multiply that by 0, both of my limits will be 0 because I multiply by 0. Does that make sense? Yes or no? That's have to be clear. Do you need me to show it to you, or are you okay with that? So then based on that, even though this limit does not exist because there's a jump discontinuity, when you take 0 and you time that, you get 0. So I don't need to find this limit. I know it's a jump discontinuity, the numbers are different, but when you multiply by 0, you get 0. If you need me to show you this, then ask me later, okay? But I can see that the limits from the point, the y value at the point x equal to 2, and the limit as x approaches 2 of the function k is the same. So I can conclude that the y value at the point is the same as the y value of the limit of function k. So is the function continuous at 2? Yes. Therefore, k is continuous at x equal to 2.